Okay, so looking at Chapter 6, Quiz Form A for notes. Number 1. We're looking at an intro stats class. They provided a 5-number summary and also the sample standard deviation and the sample mean, right? You guys see that? You guys are not paying attention today. Be on it. It says, suppose that colleges charge $73 per credit hour plus a flat fee of $35. And it says a student's taking 12 credit hours. So that means they pay 35 plus 73 times 12. That's pretty simple, right? So this is about transforming the mean and standard deviation. That's the theme of this first example. So part I of number 1 says, what is the mean fee paid? So who can help me with that? What is the mean fee paid? They're going to have the $35, right? Plus, I heard 16.65. 16.65 was the average number of credit hours, and then each credit hour is going to cost $73. So if you put that in your calculator, you're going to get the mean fee paid by a student is this much money. If you were doing this for an assignment, you'd want to write that in a complete sentence, okay? But I'm going quickly today so we can get a good start on Chapter 6. Question 2 asks, what is the standard deviation for the fees paid? This is, I think, a slight bit more tricky. So we have the standard deviation of the number of credit hours, right? So should we do this? Here's my suggestion. And compute that. Think about it.
Then you have to subtract.
There's something wrong. What are you saying, Kinsey?
You have to subtract the 35 for the...
Why do you have to subtract the 35? In fact, I should just never have put 35 in there in the first place. No.
Because it's just credit hours away.
35 has nothing to do with the spread. You can just center your z-curve. Okay, so part 3 says, what's the median fee paid? So what do you guys think? Do we need to put the 35 in there for that one or no? Yes, because that's going to affect the center of where the curve is, right? So it's going to be 35 for the median plus $73 times what was the median of number of credit hours? 16. So that one definitely is going to come up with that. So that's going to be $1,203. So we don't know anything about the shape of this data, right? But based on something you guys just saw, and against all odds number 7, you should be able to tell me whether you think this is kind of symmetric or not. Is it kind of symmetric or not? Because we don't have enough information to tell unless you use a little bit of theory here. The answer is yes. Why? Wonderful. You got it, Emery. The mean and the median are pretty close, aren't they? In fact, they're only like $47 apart. Since the mean and the median are really close, the only way that's going to happen is with real nice symmetric data. We don't know that it's a bell shape for sure, but we know it's at least symmetric. So what's going to be the better way to answer this question, with the mean and the standard deviation, or with the median and the IQR? The mean and the standard deviation, because that's what we use for symmetric things. That's what we learned in the last chapter, right? So I think we're already anticipating one of their questions here in a second, but it's good. You should see that right there. Question 4 says, what's the IQR for fees paid? You guys think we need to include the 35 for that measure of spread or not? No. Spread should not include stuff about the center. What's the IQR? You guys look at that and tell me. I know it didn't say IQR, but you should be able to look at it.
Q3.
It's quattro.
That's for sure.
So there we go. B says 28 credit hours seems like a lot. Would you consider 28 credit hours unusually high? What are they asking us to do there? Find the fences. I like that. I have a better answer. Let's see if you can come up with that in a second. So fences sound good. We should see if 28 falls beyond the maximum fence, right? So going back to our fence rule, the upper fence is going to be Q3 plus 1.5 times the IQR, right? So I just need to plug in 19 plus 1.5. Our IQR was 4. 4 times 1.5. I don't need my calculator for that. 6. So that's 25. So does 28 fall beyond that upper fence? Clearly it does. So is it an outlier? Yes, we'd say it's an outlier. But thinking back to what Emery told us a second ago, should we be using the median and IQR for this data? Or what's the better choice? We're not sure because we don't have the data. We can't see it. But it's probably a better idea to use the mean and the standard deviation. So let's see if it comes up with the same conclusion. I'm betting it probably will, but it might not. Let's see if it's an outlier according to that. So what's the fence rule for standard deviation? Well, it's real simple. You had it in your reading guide. What's a really unusual z-score? Anything, or think back to the empirical rule over here. Anything bigger than 3 is definitely incredibly rare. So is that value of 28 3 standard deviations above the mean? What's the mean? 16 point, what was it right here? 65 plus 3 standard deviations. The standard deviation was this number, wasn't it, guys?
Yeah.
2.96. What's that? You guys help me with your calculator? So the book didn't do it this way, but it should have. 19.61. So is 28 an outlier according to that criteria? Way big outlier.
I didn't calculate the 3. I didn't
Oh,
multiply by 3. I just added 1
okay.
to it. By 3, it's 25.53.
Still an outlier though, right? Totally, still an outlier. That's an unusual amount. So I'd write that in a complete sentence to finish that up. You don't have to today if you don't want to. Because we want to focus on actually doing some z-scores. So let's look at the second problem. Second problem gives you some data about this intelligence test. I don't know, it's probably one I've heard of this one. It's called the Wazir intelligence test. It's kind of like an IQ test, all right? So they say the Wazir follows a normal model and it's got a mean score of 100 and it's got a standard deviation of 15. They just said to draw and clearly label the model. Let's do that and then let's do some calculations, okay? Because that's what you're going to have a lot of in your homework. Or some of, and then we'll practice more of it next week. So, nice normal looking curve. Mine is not nice, but do what I can. So it said the mean was 100 points on this intelligence test, right? It said the standard deviation was 15. So I'm going to go 15 in either direction. So that's 85, 115. I'm going to keep going a couple standard deviations, 130, 70. I'm going to go out 3 standard deviations because 68, 95, 99.7. You guys feeling me on that one? Yeah. And then at that point, if I drew my picture nicely, which you can't trust with me, but I should have pretty much no area in those tails. I'd have 0.3% left split between the 2 tails, right? So there you go. So to label this correctly the way they want this. They want you to go and say 68% here. And then they want you to go like this. I don't know how to draw this. It's kind of hard to draw. I'd say like that is 95%. And I'm not going to draw the next one. It's just going to get too messy. The next one's 99.7%, right? So let's do a couple of calculations. Our first z-score calculations coming at you now. Let's say they asked us, what's the probability of getting this kind of intelligence score? This is how we're going to write stuff when we get to Unit 4 for probability. What's the probability of coming up with an intelligence score on this test less than 60? First, let's just guess, and then let's do the z-score and figure that out. Looking at the picture, what do you guys think? Ballpark. 60 is here, right? So here, what do we have? Well, 95% is here. That means how much is in these two tails? 2.5 each, right? So it's going to be less than 2.5 because it's somewhere right there. So we should get an answer less than 2.5. Here's how you do it. Z-scores work like this. Z, the standardized score for any normal curve. Formula you should have memorized for sure is Z equals the value, like our 60 that we're trying to investigate, minus the mean of that distribution, if we knew it, like God. So, but most of the time we just have to say what's our best guess, or what's someone tell us in a report is the best guess for the mean, you know what I mean? And then we divide by the standard deviation. So the math here is not real hard, you just got to look something up. So first we need to figure out what is that Z value. So X, we decided in this problem, was 60. The mean for this set of intelligence scores was 100. Standard deviation for this set of intelligence scores, they told us, was 15. That's going to give us the Z-score. Compute it with your calculator or whatever. It's going to be negative 40 over 15. That's negative 2.67, isn't it? Don't trust your teacher, check. Not good to trust me, especially on this event, according to the Thursday. Okay, so that's a Z-score. So now you need to look at the actual normal curve, which has a complicated mathematical expression. We're never going to use it this year. All we need to know is on the real normal curve, the Z curve, how much percent is below that spot? How much percent is below 60? So we take it to the Z curve and we find out. So in the back of your book is a table of all those percentages. There's other ways to get this, but I like to use the table. This is the standard way to do it. You've got those tables on your AP exam. We're going to get used to them. So look for page A18. A18. And I want you guys to try to figure out this table a little bit today. So try to find a Z-score of negative 2 point. You're going to see you're going to have to round this to negative 2.7. Yeah, in the back of your book. Oh, it might be different on yours. Sorry, I have a teacher's edition. They like to screw us up. You should see a Z curve. It is A78. A78, sorry. A78 in the back of your book. So I want you to try to figure out the percentage. Now, remember what I said earlier. I said all Z-scores will be referred to below. So you ask yourself this. Whenever you see this calculation, I should see a little picture on your sheet which has the middle, and on the reading guide is a question. What's the middle of every Z distribution curve? 0. And the standard deviation is always 1. That's because of the 1, 2, 3 standard deviation rule that we've been using for the empirical rule. Don't make it hard. So negative 2.67 is 1, 2, there's 3. It should be somewhere right here, and we're looking for this area. So every time you do a Z-score, I would like to have a little picture just like that, so that you can commonsensically say, this is a small percentage we should be getting. You guys feel me? If you get a large number, you should be like, no, common sense says it's a really small chance of being below 2.6 standard deviations. That's a really small chance. How small? Well, we said it was less than 2.5. This is going to tell us exactly. We're real close. So, negative 2.67. What's the number we should pull out? Who got it? Who's got it?
003.
Yeah. Mr. Johnson has it. Find it. He said 0.0038. Do you guys see that on the table? Negative 2.67. Everybody seeing it? If not, look, ask your partner. Negative 2.67. You should see 0.0038. If you're not, I'll help you out in a second here. So that's the answer, 0.0038. But I want a percentage. We don't think in decimals. How much percent is that?
99.9916%.
That's how much percent that is. That's how you do percentages from decimals, right? So that's the answer. There's a 0.38% chance of getting that kind of score. Let's do another one with the same curve. So let's do the probability of getting an intelligence score greater than, I don't know, 120. Let's go in here. What's the probability of getting an intelligence score greater than 120? So here we go. And I'm taping this, so you'll have it. You can go back and look at it. I gotta do this quick so we have enough examples. So we've got Z equals. Now we're interested in 120. The mean's still 100. The standard deviation's still 15. What's our new Z score, our standardized value? It's 20/15ths. Put that in your calculator. You'll get, what is it? 1.4? What is it? 1.3? 3333? Yeah, okay. I'm tired. Okay, so let's go figure out how much percent that corresponds to. So going to the Z table, now I'm going to look for 1.33. You guys look for that for 1 second. Let's see if you can find the number. You got it, Morgan? You guys seeing it? You think you're seeing it? I forgot to do my rule, right? Every time you do one of these, I want to see a little sketch. Doesn't have to be fancy. Here's 0. Here's 1.33. We were interested in above 1.33, so it shouldn't be a number like 56%, right? It's less than half. Definitely a lot less than half, I think. What'd you guys get? 90.82%. Does that look like 90.82%? If you see 9.9082, you're looking in the right spot. So how do you get the actual number for that green? You subtract from 100, that's it. You've always got to remember, use common sense, and it always goes below. If you use common sense, you're going to remember, because you're going to be like, 90%? No. I gotta go 100 minus it, that's the idea. So this is gonna be equal to 100% minus 90.82%, which we pull out of the Z table, so what do you get? 9.18%, thanks for the help. There you go, this is how you do Z-scores. Let's do a couple more problems, so flip it over. Go ahead and read that scenario, I think it's on dogs. We're supposed to compare two totally different distributions of dogs in this example, which is hard to do unless you use Z-scores. So we're going to do 3, and then we're going to try to do 4B. That'll be good. And remember, there'll be more examples with this if you watch Against All Odds video 8, as it says on Moodle, as it says on my board, everywhere. We'll have plenty of examples. It'll be good. Don't make Z-scores hard, because they're not. If you use your resources, you'll be fine. So we got Dalmatians and Boxers, right? So it says compare a certain Dalmatian to a certain Boxer, and it says which dog is more underweight, right? So we've got two distributions, the Dalmatian distribution and the Boxer distribution on this problem. So I'm just going to draw a quick picture. Dalmatians, what's the middle? 50. What's the standard deviation? I guess I'll just write it right here. So mu D is 50. Sigma D is, what was it? 3.3. We've got units here, we'll just remember those at the end. Okay, that's the Dalmatian distribution. Then we've got the Boxer distribution. What's its middle? 57.5, so that's its mu. And its standard deviation is what, 1.7? So their question was, which dog is more underweight? Well, I don't see any dogs here yet. You guys got me? So the women or whoever had these dogs, for the Dalmatian, how much did the Dalmatian we're looking at weigh?
45.
45, so put 45 on there. Let's see what percentage of dogs weighed less than that. And then for the boxer, how much was the boxer we're supposed to look at?
52.
This person's really worried about their boxer. They've got a prize fighter, you know, that kind of thing. So just when you have a big, quick sketch like this, it's hard to say, right? They're both kind of in the same area. What would have made this nicer and easier to tell which is more underweight if I had labeled it nicely and actually drawn a good picture, right? If I would have like counted by 1.7s down here and counted down and up by 3.3s right there. You guys in your head, if you think about 3.3 and 1.7, should already be able to think about which one's more rare. Well, let's do a proof using z-scores, okay? So what's the z-score for this Dalmatian? I'll do it in green. So it's going to be X, the individual, minus the mean of the Dalmatians over how much they're spread apart, 3.3. Turn that into a z-score, and then our table will compute it into a percentage. So what is that, -5 over 3.3? That's like negative something, I don't know, 1.515 you said? So I'm going to say 5.2 because that's how our table works, if you guys have been using it already. Yeah. Let's just do the same thing over here. So this z-score is going to be the boxer itself minus the average of all boxers. I guess God had to give us that. I don't know if I believe it, but okay. Over how much the boxer distribution is spread apart. Stick it in your calculator, not in your teacher's head. Whoa, I can't do that. Negative 2.9 something. What is it?
3.24.
Gosh. 3.24. Okay, and now we're going to go to our z-tables and figure out what percentages these correspond to, and we can answer the question, bottom line. In fact, I don't even think you need to find the percentages. We will, but you should be able to just take these numbers and now decide which dog is more underweight, the red one or the green one. The red one. The red one is 3 standard deviations below what an average weight is for its population of boxers. The green one's only 1.5 standard deviations, not nearly as rare of a value. So right there we could answer the question. Just for practice though, let's go to our z-table and practice, okay? What's the percentage for this one?
Around 6-ish.
You guys all to look. Negative 1.52. We got below on both these, you guys see? So we won't have to go 100% minus on either one. So right there we're going to go with negative 1.52. I see 0.0643. So if you're watching the video, you definitely need to pull out your table and do these along with us. So I see 0.0643. Does that mean this is 0.0643%?
No.
No.
6.4.
It's 6.43%. And for that one, do the same thing. If you're thinking about the empirical rule here, that's -3 standard deviations below the mean. Think about it. 99.7% is 3 standard deviations like this. So the percentage we should get should be less than 0.15. You feel what I'm saying? So we got 0.3 in the tails, so it should be less than 0.15, is it? -3.2. It's 0.30. This comes up with on our table that which is 0.06%. which, by golly, is less than 0.15 as it should have been. Because if this was exactly -3, the answer would have been 0.15%. Does that make sense? Because 99.7, you've got 0.3, cut it in half, 0.15. Okay? And if you're still not quite comfortable with that, practice, you'll get comfortable with it, I promise. You guys all have good number sense. So. Okay, let's look at one more question before we leave today, and I might cut you off. I might go over the bell a tiny bit, so I'd hang around if I was you. I'll try not to do it too much. Number 4, let's just do part B. It says human body temperatures are taken, and this is kind of a weird problem set up, so it says they're like 0.5% lower than orally versus ear. Let's not make this hard. It says first find, part B, find the interquartile range for ear temperatures. So, our curve, once again, ear temperatures. Why don't you guys skim that problem and tell me what is the mean for ear temperatures? For 98.7, you guys agree? Is that the ear one? So I got a little bit confused when I read it. There was like the ear, and then there was the 0.5 less for like the oral. This one's focusing on the ear. I think Montana is correct. 98.7 is what they said was the mean for ear temperatures. What's the standard deviation for ear temperatures? What was it? 0.7? Okay. Now this question was different. They didn't ask about a specific spot. They said turn something with means and standard deviations into the interquartile range. That should make you go, huh? I thought we kept them separate. We do keep them separate in statistics, but that doesn't mean you can't translate one into the other. So the interquartile range, what can you guys tell me about quartiles? Quartile 1, what's that mean? Has to do with the median. Ah, it's where 25% is below. Okay, so we want to know where 25% is down here for quartile 1. So this is the way you use your table in the back of the book backwards. Look at your table in the book and try to find the closest thing you can to 25%. It's going to take you a second. Look for it. You might not hit it exactly. Try to find the closest thing to 25% you can in there. You're going to have to search for a second. Is it exact? Nice. All right, but hold on to it if you've got it already. It's going to take a couple of us a second. It always takes me a second. 25%.
Oh yeah, never mind. I found it.
It's not exact.
I found the point.
You guys see 0.248 in there. And then right next to 0.248 is 0.2514. 0.25 is actually right in the middle of those. So 0.248 is a z-score of what? Negative 0.68. And 0.2514 is negative 0.6. So what is a better guess? We've got that the z-score is between negative 0.67 and negative 0.67. So I liked it, negative 0.675. That's the z-score we want for quartile 1. So I'm going to call it z sub q1 is negative 0.675. Now we've just got to work backwards, and we'll be able to get the value on there like we want, which will be in the 90s, right? Somewhere in the 90s. So we're just going to say, oh yeah, z is x minus mu over sigma. We know the z-score, which is going to give us 25%. We don't know the value, but we do know mu. What's mu? 8.7. We also know the spread. We know the standard deviation is right there, 0.7. Can we solve this little equation for x? I think so. First you multiply by 0.7. Why don't you guys do that? I don't have a calculator on me. What is this times 0.7? It's negative 0.4? 4725. And the easiest algebra problem ever, to get x by itself, what do you do to both sides? Add 98.7 on both sides. So what's that plus 98.7? 98.2?
Yeah.
Give me more decimals.
2275.
Thank you, Kinsey. That is quartile 1. How do you find quartile 3? Because to get the IQR, don't you need Q3 and you also need Q1? Well, you do the same kind of thing. Except you want 25% above. So now I want you guys to find the z-score for 25% above. You gotta catch a bus, you can go. If not, I'd stick around for a second. It'll be in the video, Tyler. And you kind of got the idea already, right? I'm just doing the same thing again. So.
Students, just a reminder, if you ride Michelle's bus, number 41, get on bus 3. If you ride Doyle's
So you
bus,
have to
number
do the
353,
opposite.
get on bus 67.
25, yeah. 75.
We should see something here. Look for 0.75. What's the number?
It's just positive 0.6.
Think about why the value you found, instead of being negative 0.675, this is perfectly symmetric. So it should really just be 0.675. So now we're going to do another z-score and put 0.675, because that is the value of z quartile 3. We're going to solve that equation. So if you solve that equation, you end up getting, let's see. You guys have a good weekend. You end up getting 99.2. And now you've got the quartiles, so you can find the IQR pretty simply. Subtract them and you're done. So the IQR that they were asking us for here is quartile 3 minus quartile 1. Weekend max. Which pretty much comes out to about 1.0. And I'm going to stick my units in here. This is degrees Fahrenheit. So that's the spread. If you're watching the video, definitely make sure that you're pulling those z-score values when they're doing them backwards and when you're doing them forwards out of the chart. That's extremely important. I'll see you next time.